All right, everybody, lecture 8. We are now going to take a look at another family of arguments called teleological arguments. And teleological arguments are precisely that, just another family, right? Now, structurally speaking, the way they sort of move and structure their arguments, they oftentimes will function very similarly to the cosmological arguments that we've already seen. They start with a particular phenomenon, they argue from that phenomenon to God's existence. All of them do that. Cosmological arguments start from the universe. That's the phenomenon they argue from, down to God's existence. With teleological arguments, basically we start off with some particular detail or design or purpose or function within the universe, so some particular little aspect of it, and we argue from that aspect to the existence of God. So the word telos means purpose or meaning or something like that, and these arguments build on the aspects of nature that appear to have purpose or design in them. Maybe that's the way blood clots. Maybe that's the way the eyeball functions. Maybe that's the way atoms are built. Maybe that's the way gravity works. Maybe that's the distance of planets from each other in our solar system. All that to say, there are lots and lots and lots of particular features of the physical world that these arguments will point to and say, aha, this little feature right here has to have design. And if there's design, there's a designer. So that's essentially what they do. Again, structurally, they kind of move similar to cosmological arguments, but they use specific data, right? And so we're going to look at two versions of teleological arguments here in this one. Again, what I want you to know is that this is just a family of arguments, and there's lots and lots of examples of them. There's no way I could exhaust them all. I just need to try to give you a flavor of them to help you sort of navigate this. Well, in many ways, these kind of arguments were popularized by a guy named William Paley. William Paley was a pastor in England in the late 1700s and then early 1800s, and he wrote a little book called Natural Theology, published in 1802. This is what, I guess about 26 years after the American Revolution began. This work was deeply influential in England and Europe, and then also in the United States. And I'm going to read the quote here in just a minute. But in short, whereas most philosophy had moved in a very atheistic way, there was still one major thing that kept the Western world from just going wholesale secular, intellectually speaking. That is, despite their philosophy being very secular, they really hadn't figured out a way to do science in a very secular way, because it seemed like the physical world required a designer, and they didn't have a naturalistic explanation for how all this stuff could be. Paley vocalizes this argument in 1802. It's very popular. Interestingly, philosophical arguments against these kinds of arguments were already laid down 26 years before this in 1776 by David Hume in his Essays on Natural Religion, or no, Dialogues on Natural Religion. He leveled some stinging criticisms of Paley's kind of argument. But be that as it may, the philosophical arguments being as strong as they were, it was the science of everything that caused people to hang on to the notion that Paley's argument is going to give us. I'll show it to you in just a second. Okay? You say, what changed then for Paley? Well, Paley writes in 1802, and there's this little book called The Origin of Species in 1859. So 57 years later, Darwin is going to write his very influential book. And the reason that's influential is because Darwin gave to naturalists a mechanism that they could explain all the stuff that God was needed to explain prior to that. And so and frankly, that's what makes Darwin Darwin. Look, there had been plenty of other evolutionists. Even back in the ancient philosophers, there were evolutionists. There are even some early church fathers that postulated some evolutionary theories. Augustine. And so look, evolution's not what made Darwin Darwin. What makes Darwin Darwin is that he gave a naturalistic explanation of how it could happen. Once that happens in 1859, you didn't need the kinds of explanations that Paley's going to offer us here, and hence teleological arguments kind of tank from this point forward. Now, I'll show you Paley's arguments, then I'll show you some modern contemporary arguments, and they're much more persuasive, and they don't have the same kinds of problems that Paley's argument is going to have. Okay? All right. We start off with Paley. Paley, at the beginning of the Natural Theology, there's this famous quote. It's a big quote. It's 2 slides. Just bear with me, because this quote kind of gives you the intuition or the ethos of teleological arguments. Okay? He says, quote, "In crossing a heath," I guess that's like, I don't know what that means, woods or something like that. Suppose I pitched my foot against a stone and were asked where the stone came to be there. I might possibly answer that for anything I knew to the contrary, it had lain there forever. Nor would it perhaps be very easy to show the absurdity of this answer. So in other words, what he's saying is, look, if you're walking through the woods and you hit your foot against a rock, and somebody asks you, where'd the rock come from? You just very instinctively say, I don't know, the rock's been there forever. And nobody thinks anything about it, okay? But suppose I had found a watch upon the ground, and it should be inquired how the watch happened to be there. Paley says, I should hardly think that the answer to which I had given before about the rock, that for anything I knew the watch had been there, had always been there. He said, in other words, I can't give you that answer about the watch. But why? Why should not this answer serve for the watch as well as for the stone? Why is it not as admissible in the second case as in the first? In other words, what Paley's wanting to know here is, why can't you just simply say that the watch has been there forever like you could for the rock? There's something different about the watch than the rock. And he says this, for this reason and no other, when we come to inspect the watch, unlike the rock, we perceive that it has several parts are framed and put together for a purpose. That is, that they are so formed and adjusted as to produce motion, and that motion so regulated as to point out the hour of the day, that if the several parts had been differently shaped from what they are, of a different size from what they are, or placed after any other manner, in other words, structured the way they are, or in any other order than that which they are placed, either no motion at all would have carried on in the machine, or none which would have answered the use that is now served by it. And so in other words, the reason you can't, the rock you can say, man, it's been there forever. A watch, you can't do that. Why? Because there's something specific about the watch. The watch has design to it. It has contrivance to it. It's clearly been put together, thought through. As you examine it, clearly that's the case, and therefore the watch is different. Now, what Paley is going to argue from that is, such is the case with a lot of things in the world. It has design to it, and look, if that works for the watch, then it works for DNA, which they didn't know about DNA, but it worked for the eyeball, it worked for the clotting of blood, it worked for the skeletal system. These are all the things that Paley's going to point to in 1802. Skeletal systems, and the way blood clots, and the way eyes work, and all this stuff. They understood the mechanics of that stuff, and it blew their mind. They said, if you have to have a design for a watch, you got to have a design for this stuff in nature. Now, just real quick, here was the problem with that argument philosophically. It's an argument from analogy. And sometimes analogies, that is similarities in two objects, they don't necessarily prove similarity in some other regard as well. And so that was the problem with them, okay? But nevertheless, here are the kinds of arguments that Paley would put forward, and others since him would put forward. He would say something like this. Premise one, human artifacts are products of intelligent design, like watches, right? Okay, and we can look at the details of them and see why. Well, two, the universe resembles human artifacts in that they have contrivance and design and mechanism to them. Premise three, therefore the universe is a product of intelligent design. Premise four, but the universe is complex and gigantic in comparison to human artifacts. That is to say, if you think that for watches, then even more so for human art than for the universe, because it's even bigger and more spectacular. Conclusion, therefore, there is a powerful and vastly intelligent designer who created the universe. Now, as I've said, the weakness of this argument, as Hume would argue, is that it seems to have a dependence on the analogy between human artifacts and things in the universe. And for many philosophers, those analogies can prove weak sometimes, okay? So, for example, just do this. My shirt is blue. This book is blue. Since these two are alike in one regard, their blueness, right? Here's another regard. My shirt is physical. This book is physical, right? Okay, great. So these two are alike with two characteristics. If they're alike with two characteristics, they must be alike with a third. This book is made of paper. This shirt is made of... No, it's not. It's made of cloth. This shirt is made of cloth. This book is made of paper. So just because they're alike with regard to two things doesn't mean they're alike with regard to a third thing. That's the problem with those arguments. Just because the watch and the universe seem to have these things, and you can say in the case of a watch for sure that it has a designer. Hume and others are not denying that watches have designers. What they're saying is that you can't argue from analogy of the similarities to a designer to the universe, okay? And that is a concern, okay? Well, here's the good news. These arguments are not dead. There's ways to rebuild these arguments in such a way that you don't have to depend on the analogy to make the point of a designer. There's actual intelligence that we could point to and stuff like that. So let me just give you one more contemporary kind of argument that you could make. This comes from William Dembski and Michael Denton. They make this kind of fine-tuning argument. Okay, now I'm going to define what we mean by fine-tuning here in just a second. Okay, fine-tuning. The fine-tuning data. Pause right there. In just a minute, I'll come back and walk through the rest of the argument. Let's get clear first on what exactly do we mean by fine-tuning data. Let me give you one example. An example of this could be the way an atom holds together. This is just one example, but there are lots and lots and lots of other examples that you could point to. I'm coming right back to the slide because I'm going to just give you an example of fine-tuning from the atom. But let me hold this book up. If you're interested in more cases of fine-tuning, I'd refer you to Alistair McGrath's Fine-Tune Universe. Now, I will just give you a heads up. He's committed to evolution in this book. I'm not endorsing it for that reason. He's arguing, even as someone committed to evolution, that even given that, you still have to have something outside tinkering with this and setting it up, okay? I'm not endorsing the book because of the evolutionary stuff in it. I'm endorsing the book because if you want a good catalog of the kinds of evidence that we could marshal that show us fine-tuning, this is a really good resource for you, okay? And there's lots of other ones as well, but that's just one resource that you could point to get an example of some fine-tuning data. All right, let me just give you this one example of the kinds of stuff we mean when we talk about fine-tuning data, all right? And then I'm coming right back to that argument that I just showed you, and we'll walk through that argument together, and I'll help you see some of its key premises. Take this atom, for example. The question is, what holds that atom together? Right? It's really strange that that little bitty thing stays together the way that it does. We probably never even think about that thing, but something's holding it together, and there's actually two forces here, at least two forces. There's actually many, many more, and I tremble lest any of you have a background in, like, physics and stuff like that. Hey, I'm a philosopher, just bear with me. I think I understand the basic premise here about this, and I can explain it to you, and it's just baffling to me that this happens, all right? But notice the structure of an atom. You've got your nucleus in the middle, made up of your protons and neutrons, right? You got your electrons that orbit around the atom. They zip around the atom with incredible speed. Now, if you know anything about something that goes around and around and around in a circle, you know that there's force that's exerted outwardly, right? We call it centrifugal force. If you took a bucket of water, for example, and you held it like this, the water stays in the bucket. You take that bucket of water, though, and you turn it upside down, the water all pours out, right? Okay. Now, if you take the bucket, though, and you sling it around like this, around and around and around and around, the water stays in the bucket even when it's upside down, right? Why doesn't the water fall out when it's upside down? Because of centrifugal force. It's literally the motion of doing this with the bucket is slinging the water outwardly, but it's being held by the bottom of the bucket and the sides of the bucket. But there's still an outward force of tremendous pressure being exerted on that water as it's slinging around. So all that to say, when you look at this atom, here's what you need to see. This electron zipping around, going so fast, there is an incredible amount of energy being exerted outwardly here. So much so that you have to wonder, why is that little electron not zipping off and just going boof? It's slinging outward. Why? What keeps it from slinging off and the atom dissolving? Well, because this little guy here is exerting a different, an opposite force. While the centrifugal force slings it outwardly, the nuclear force from the nucleus of the atom pulls it back in like gravity, right? So here's what you got to see. There's one really powerful force slinging it out, and there's another force pulling it in. Now, what would happen if either of those two forces was a little bit stronger? If the centrifugal force was just a little bit stronger than the nuclear force, that centrifugal force would sling the electrons outward, atoms would dissolve and dissipate, and then literally nothing could exist in the physical world. No physical universe. It'd just be little molecules going everywhere, or little particles going everywhere, okay? What would happen if the nuclear force were a little stronger? Well, despite the centrifugal force, it would suck those electrons back in and all the atoms would collapse back on themselves, and once again you would have no atoms, or you would have dysfunctional little bits and blobs of things, right? Here's the point. There has to be a perfect, a razor thin balance of these two opposite forces. That balance seems to have been finely tuned, and if it's not exactly perfect, then atoms don't exist, okay? This is an example of fine-tuning. We could multiply these over again and again and again. We could talk about the distance of stars. We could talk about the distance of planets. We could talk about plate tectonics. We could talk about the way blood clots. We could talk about the way cells in their body work. We could point to any number of things, from really, really big stuff in the universe to really, really small stuff in atoms and neutrons. Bottom line is, all of this physical stuff seems to have been perfectly tuned, exactly right. And that can be used as an argument for God's existence. Okay, so now back to the argument. This is the exact same argument. The only thing is I didn't underline the fine-tuning, because now we've explained what we mean by that. All right, so here's the argument. It's going to say something like this. Premise 1, the fine-tuning, the example I just gave you, and lots more, that stuff are either the result of chance, in other words, that balance just happened by dumb luck chance, natural law, there's something in nature that makes it happen that way, both chance and natural law, or design. Okay. Now, they're going to argue then the fine-tuning data are not the result of chance, natural law, or a combination of both. Why do we say that? It's not just analogy. Watch this. They think they can eliminate these other possibilities and argue for design, since the data are contingent, complex, and specified. What we'd want to know, are there any criteria that we could use to determine that? And that's what they're suggesting we have. Contingency, complexity, and specificity. I'll explain what we mean by those in a minute. If the argument works, though, and I'm going to come back to argue this stuff here, if the argument works, then that's going to mean, number one, conclusion 1, well, therefore, the data are the result of design, and conclusion 2, therefore, there is a designer to it all. The question is going to be, how would we know if it's design and not just dumb luck from chance and natural law? Okay? Well, they think that these factors right here, which are discernible, are the way we would determine that. Now, very quickly, maybe you've heard of the SETI research program. SETI, S-E-T-I, Search for Extraterrestrial Intelligence. This is a decades-long project, an international project, where scientists all over the world have been basically listening to outer space to try to figure out if indeed anybody is out there that's trying to communicate with us. As we turn our telescopes up into the sky and listen and kind of tune in to the sounds of the universe coming at us, we're listening to hear if there's any intelligence out there, okay? Now here's what we hear. We just hear static. We don't hear any sounds that are discernible as intelligence. Now here's the thing though. Imagine as you listen to that background sound, you were to hear a different sound all of a sudden. How would you know if that different sound is intelligence or just dumb luck in nature? How would we know? Well, what they're going to argue is we're looking for 3 things: contingency, complexity, and specificity. So what do we mean by that? This is what's key in premise 2. The fine-tuning data are not the result of chance, natural law, or a combination of both. Since why? They have complexity, contingency, and specificity. What do these 3 things mean? Well, here's what we mean by that. Complexity. The information contains a pattern of some kind, like the sound of this: 111, 112, 113, 114, 115, as opposed to some simple sequence like 1111111111111, right? No, if you heard 111, 112, 113, 114, 115, there's a little bit of a pattern there. Now it's not much, but there's a little. That is to say, there's a complexity to it. Okay, but that in and of itself is not enough. The next question is it contingent? In other words, did the information have to be there? Is there anything about nature itself that requires 111, 112, 113, 114, 115? And if the answer to that question is no, nature doesn't require that sound, then we've got complexity, we've got contingency, which means it's dependent on an agent of some kind. But here's the next big thing we want to look for: specificity. That is to say, does the information yield something differentiated? Is there a new message? So to illustrate it, imagine I'm going through the woods and I see a bunch of trees, and all the trees just have bark on them, and the bark just looks random and looks natural. When I see that bark, I don't see anything like that. But when I see this on the tree, Bill loves Mary, carved into the bark, well, then I know that that's a person that did that, not just nature that did that, right? Why? Because it's got complexity. There's a pattern to it. Contingency, it doesn't have to be there. And it's specified. It tells me something, namely that there's a guy named Bill, and evidently his heart is beating for Mary. He loves Mary. So all that to say, we can look at that stuff and we can say, no, that's intelligence right there. Okay? Now again, here's the argument. All right? Here's the argument. Again, the fine-tuning data, they're the result of either chance, natural law, both, or design. Premise 2, they're not the result of chance or natural law or combination of them, since they display contingency, complexity, and specificity. Go back for just a second. That fine-tuning in that atom there certainly demonstrates those three criterion. And if that's true, therefore, the data are the result of design. And conclusion 2, if there's a design, there is a designer. And so in short, this is the way teleological arguments kind of work. I've just given you 2 examples. There are, again, lots and lots and lots of other examples that you could look at, but I think that helps us get the gist of them. And in the Groteist book, there's some other ones that we could look at. Just very quickly, I mentioned this book in the last lecture, and then I never showed it to you. If you're interested in these kinds of arguments, you can check out this book. There's tons and tons of materials. I give you lots and lots more. But this is a book by Eugen Nagasawa. He was my PhD supervisor at Birmingham. He wrote a book called The Existence of God. Interestingly, Eugen is not a Christian. In fact, he's not religious at all, but he is persuaded that there is a God from some of these arguments. And so that's very interesting. So you could get sort of this objective view here from some of these folks, and he will sort of trace through some of these arguments. He doesn't agree with them all. Some of them he thinks are really poor, but some of them he thinks are really good. So anyway, those are examples of fine-tuning arguments. Hope that helps. I believe in the next lecture we look at moral arguments. We'll see you then.